Okay, so next, I'm going to speak more about securing the management plane. We've just seen, let's say, one of the biggest portion of the management plane, which was the management of the device itself in order to configure it. Next, we're going to look at variation of other protocols which are part of the management plane. We'll see exactly how those are being configured and what those are being useful for to begin with. So first we have Syslog, which it is basically logging, nothing else but that. Now logging is being used for a couple of, let's say, reasons. It is used in order to monitor the network, like when an interface went down on a specific device, you would want to be alerted on a specific platform. So you might want to take action, either manual action, call your ISP that a link went down, or maybe an automatic action. Maybe you would choose to automatically run a script and reconfigure a router to reconfigure routing, for example. So either way, monitoring is used in such use cases. When something happens in the network, you might want to receive a log message, and then you might also want to be informed by an alarm that something happened, and also you can automatically take some actions in the network. It's also used for auditing purposes, like for example ACL logging. So whenever you want to configure an ACL in the network with the scope, of course, of filtering traffic, you may use the logging keyword so that all traffic matching that ACL back and forth to the router is going to also create log messages. So whenever, for example, ACL logging is useful. Like let's say you assume that this PCA is infected. For example, you assume that you believe that something happened and is being infected with a specific virus or worm, and that this PCA is going to start sending packets destined to TCP port 445. So what you might want to do on the default gateway of that PC, which is router 3, you may want to configure in here inbound an access list. We're going to say permit TCP any equal 445, and then you put the logging keyword attached to the entry, and then also permit IP any. So you put an ACL inbound on the default gateway's interface, where you're basically allowing, with the last line, you're allowing all IP traffic inbound. That's permit IP any with no logging keyword. But on the first line, you're matching on that specific traffic destined to port 445 with the logging keyword. So whenever the user is going to send traffic or the PC is going to send traffic by itself on TCP port 445, the router is going to generate the log message. So you're going to know that that's going to be a confirmation that the PC is actually sending traffic on that port, which means it's being infected as you assumed in the first place. It's also used for troubleshooting purposes. Debugging level. So you're going to be able to log at the debugging level. So when you run any kind of debug commands on a router to investigate a specific problem, you're going to make use of the logging level to get as much output as possible in order to investigate a problem. And also for forensic analysis, like incident investigation. So if something happened in the network, you may want the network to previously have logged all kind of messages to whatever happened in the network, so that you're able to not only investigate and trace who was the victim and who was the attacker, but also at which point that happened. So logging helps in various use cases, to call it that way. Now a router, I said generically a router, but this can be of course a switch or a firewall. So a network device in general. Let's speak of course about Cisco. This is a Cisco course. Can be configured to send log messages to console, to VTI lines, to the buffer, or to a remote Syslog server. So it can be configured to send log messages to one or multiple of those destinations. It can even send the same log message to all of them at the same time. So like if you configure ACL logging on the router, and as we were saying before, and the router identifies traffic matching an ACL line with the logging keyword, you may configure the router to send log messages to all of those destinations, to the console, VTN lines, buffer, and remote Syslog server. Now, a default Syslog runs when you're going to send log messages to a remote Syslog server to collect them and store them, and or to remote CM server to collect them and correlate them to identify any kind of attack patterns. Either way, when you send log messages to a remote Syslog server, that is being sent over UDP 514 port by default. Optionally, you can change the UDP port number, or you can also transition over TCP instead of UDP. So now, why would you use TCP instead of UDP? Not all Syslog servers support TCP transfer for Syslog messages. It is because clearly UDP is connectionless. So what that means is that the router is going to send the log messages to the Syslog server, but it's going to be no confirmation if the log message actually reached the Syslog server, or it has been lost in transit, or whatever happened with the packet. So ideally, you could possibly implement TCP to make sure that there are no lost log messages in the network because of transient network issues, or because of the Syslog server had a problem. You may choose in the end to use TCP, which means that the router is going to constantly keep trying to send the log messages to the Syslog server until it's going to succeed in the end. Because TCP is reliable, so it's also gonna TCP is not affected by packet drops, while UDP is going to be affected by packet drops, which again, UDP cannot guarantee that the log message issued by the router towards the Syslog server has actually reached the Syslog server in the end. Now, when you choose to log messages at different destinations, all of them or some of them, you can configure the logging level, for the system, with level 7 providing the most output. So you have a 0 to 7 logging levels, which clearly 0 means emergencies. So that means that if you configure, for example, the console to log only emergencies, you're gonna be seeing on a console very rare log messages only when there's an emergency on the router itself, like it has a critical CPU, high CPU problem, or it has a hardware failure. Is gonna generate a log message because that's an emergency. So emergency doesn't mean that there's an emergency in the network, because the router cannot know if it's a problem in the network. Emergency it's related to the state of the router, not the state of the network. Then alerts is going to be clearly other kind of messages whenever the router wants to send some alert messages. Then you have critical, errors, warnings, notification, information, and debugging. And now you should never enable 11.7 at the console. It will melt down the router CPU. So whenever you want to do debugging on the router, I mean, in a test environment, you can do whatever. It doesn't matter, of course, because even if you enable debugging level at the console and then you activate the debug, it's not going to crash the router or melt the CPU, because it's not. There is no traffic, real life traffic transiting to the router to end up with a huge amount of output as a result of the debugging being performed. But on a real network device, if you say, for example, debug IP packet, for example, which is one bad example, it means that at that point you would want the router to show you an output of all of the packets passing back and forth to the router. So you can imagine that in a real life network situation where a router passes back and forth hundreds and hundreds of megabits per second, then it's not going to be able to put all of those log messages at the console, and even trying to do that is going to cause a high CPU, and when the CPU goes to 80, 90, 100%, then unexpected behavior can happen, which means the router can crash, can reload, is going to start losing packets from the control plane. It's basically problems. So ideally in production network, you leave the console with informational enable logging or notifications, but no way debugging. in a production network. You could enable debugging in general at the buffer. So if you want to investigate a problem, you'd go ahead and log in debugging at the buffer, then run the proper debug command, and then look in the buffer to see the result of the debugging. That's the safest way to go. So debugging level should be performed in general only to the buffer, never to the console. In general, not to the VTI lines, because of the same reason it can crash the CPU. And also in general never to the Syslog server, because on the Syslog server you don't need debugging level output. So ideally in general you're going to leave the console and the VTI lines to have level 5 or 6. It depends what you want to see as log messages on the console or VTI. You're going to go on the buffer and you could configure on the buffer debugging level, and then on the Syslog server you would in general use informational level, because you would want to see the most log messages, but at the same time not too many log messages like debugging, because that's not the level which is required for a Syslog server to actually gather a lot of information, required information from the log messages. Now, Syslog configuration steps. So this is in general in kind of like all networks where they have they think about security. In all networks, Syslog is a important security tool, to call it that way. So first of all, you enable logging by the logging on command. By default, this is enabled, but in case it was disabled, you just have to make sure that's in there, logging on. And then you define console or VTI or buffer as destinations. You can configure one or all of them with, of course, the proper level. So logging console is going to be in general like logging console notifications or informational. Logging monitor, usually the same thing, notifications or informational. And logging buffer is going to be, could be debugging. And with logging buffer, we can also configure not only the level of logging, but also the buffer size. Because depending on the debug you want to run, you may need to have a larger buffer to make sure that all of the debug output can be retained by the router in the buffer. Now the buffer size, of course, depends from router to router, because it's going to be in the end a portion of the memory that the router has overall. So based on basically the bigger the router, then the bigger the buffers which are available for logging. And of course, optionally you can define Syslog server destination. You're saying logging host and the IP address of the Syslog server, and then you also define the level to be logged at the Syslog server, like so logging trap and whatever the level is. Verification steps. It's plain simple to verify logging configuration and display logs stored in buffer. So the show logging command, as you're going to see, not only you see the logging configuration, but you also see the buffer, the logs stored in the buffer. Now the buffer is circular, so what that means is that if the buffer is configured to be in size of 1 megabyte, then if it gets full, then the newly upcoming messages to be stored in the buffer are going to overwrite the oldest messages from the buffer. So it's a circular buffer. When it reaches its maximum capacity, the router is going to start deleting older messages to make room for newer messages in the buffer. That's why it's called circular. You can also display, if you enable logging at the VTI lines, in order to see those log messages at VTI lines, as you're on a VTI session, you have to configure terminal monitoring there. Otherwise, even if logging to the VTI lines is configured, you're not going to see anything at the VTI line session, so via Telnet or SSH, unless you put this command in user exec mode. Okay. Now before we move on, let's go to the configuration side real fast and let's see how that goes. Let's see if you have any questions before we move on. Not really. Okay. So what we're going to be doing next is speaking about the Syslog server. We're going to do the following. I'm going to go on router 2 and configure logging, and I'm configure logging at the console to be informational level, so level 6. At VTI lines to be likewise informational, level 6. At the buffer to be likewise, at the buffer to be debugging level, so 7. This is level 6, this is level 6, and this is level 7. And then at the syslog server, I'm going to say, likewise, let's say informational. So 6. And the syslog server is going to be testpca. So testpca is going to be running a syslog server. Now testpca has an IP address via DHCP. So I gotta see what is the assigned IP address via DHCP on testpca before I can know the IP address of the syslog server. Of course, in the production network, your syslog server is going to have a static IP address, because if the IP address changes, then clearly you're not going to be able to send the log messages to the appropriate syslog server destination if the syslog server's IP address changes constantly because it's DHCP assigned without a reservation.